Hi chemists, my name is Kim and in this video we are going to be continuing with organic chemistry. We're going to be talking about naming and telling the difference between aldehydes and ketones. So more practice with naming compounds using table R to identify which type or class of organic compound we have. Let's go. Let's start by finding aldehydes and ketones on table R. So I see them down there in the 4th row and the 5th row. Aldehydes and ketones look similar to each other at first glance. They both contain what's called a carbonyl group. That's that carbon double bonded to an oxygen and then bonded to two more things. You'll notice that organic acids and esters also contain carbon double bonded to an oxygen in the chain. What's different about all four of these functional groups is what else that carbon is bonded to besides that double bond to the oxygen. So for aldehydes and ketones specifically, so we're going to be focusing on in this video, we're going to be looking at a double bond to carbon and either a hydrogen coming off of that carbon or another carbon coming off of that carbon. Let's start with aldehydes. An aldehyde has a functional group that can be described as a carbon atom at the end of a carbon chain. So either at the beginning or the end, but not in the middle. Double bonded to one oxygen atom and then single bonded to a hydrogen atom. Its fourth bond, because it's got two bonds to oxygen, one bond to hydrogen, its fourth bond is connecting it to the rest of the carbon chain. Its general formula is R bonded to carbon, double bonded to an oxygen, where R is any group of bonded atoms. Notice that carbon is double bonded to an oxygen, then bonded to a hydrogen. To name aldehyde, it's actually quite straightforward. You count the number of carbons in the chain, and then name that parent chain as if it was an alkane using table P. Finally, remove the E at the end of your name and replace it with al, as the suffix. And that al, at the end, tells us that we have an aldehyde. So here's an example. Propanol is the example that's given to us in table R. Let's think about how propanol would look. That propan, P-R-O-P-A-N, that would be propane if we took off the Al at the end and added back the E. Propane would be a 3-carbon alkane. So this is telling me that I have 3 carbons, and at the end, because it's an aldehyde, I don't need to worry about numbering my carbons at all. There's no number in the whole formula because the double bond oxygen is always going to be at the end of the chain, so you don't need to worry about numbering it. So 1, 2, 3, on the end of the chain, I am double bonding an oxygen to the end carbon and single bonding a hydrogen off of that carbon as well. This would be propanol. Don't mix it up with propanol, OL. I know that these endings, these suffixes are very similar to each other. This is propanol, not propanol. Propanol would be an alcohol. Let's look at a ketone. So the difference for a ketone is that that carbon atom is in the middle of a carbon chain. That carbon atom is double bonded to one oxygen atom and then bonded to another carbon atom. Our general formula of a ketone is very similar to our general formula of an aldehyde, but now I've got that carbon bonded to an R prime instead of an H on the other side. To name ketones, I'm going to count the number of carbons in each chain and name it as if it was an alkane, just like when I was naming an aldehyde. This time, I will remove the E at the end and add one as the suffix, O-N-E. And I will put the number that the oxygen comes off the carbon chain at the start of the name. The anone at the end tells me that I have a ketone here. 2-pentanone is going to be the example that the table R gives us for how to name a ketone. So examining that formula, I know that I've got pentane as my backbone of my alkane, so that's going to be 5 carbons. And then the O-N-E at the end tells me that I have a ketone. So I've got pentanone. So I'm going to draw 5 carbons in a chain. And the 2 tells me that the double bonded oxygen is coming off of my second carbon. Now, I could number my carbons like this, or I could draw it in reverse and number my carbons like this. Either of these structures would be 2-pentanone because the carbons can be numbered either way. Let's do 2 practice problems before we finish. First one, what would the name of this compound be? Pause the video if you need more time. Notice how tricky it is to differentiate between all these different endings. I know it's cruel, but pay careful attention. This is propanol. I can tell that it's propanol because it's an aldehyde. I've got an aldehyde group right here, C double bonded to O, single bonded to H. That is an aldehyde. It doesn't match any of the other functional groups. So I've got propanol. Let's try this one. All right. This is going to be 3-hexanone. It's not 4-hexanone because look, I can count like this. 1, 2, 3. And so even though I count 1, 2, 3, 4, I would like to put my double bonded oxygen coming off of my smallest number carbon. So I want to count from right to left. 1, 2, 3, hexanone. It's hexanone because this is a ketone. This was really tricky. They tried to trick you in this question into thinking that maybe you had an ether or maybe you had an ester. But notice in an ether, the oxygen would be in the chain, and it's not. And in an ester looks really similar, but in an ester, the carbon is double bonded to an oxygen and then single bonded to another oxygen in the chain. And that's not happening here. This is definitely a ketone, so the name would be 3-hexanone. Let's check back in on our learning goals. Hopefully, you feel more comfortable determining the difference between an aldehyde and a ketone, and naming a ketone or coming up with identifying its structural formula based on its name. Remember to use table R to guide you. Lots of great information is in that table. Nice job today.